Hello, everyone. This is Mr. H. I have another video that I wanted to do for my students. Today is June 8th, and this week we are working on the mathematical concept of scale drawings and proportionality. So let me jump into it. I have a lesson that I wanted to do. All right, so here's what we're doing this week, or here's what we're doing today, June 8th. The lesson is about proportionality and specifically scale drawings. And then after that, we're going to do Khan Academy. And on Wednesday, we have an iReady lesson, and they're both on scale drawings. Now, at the beginning of our distance learning, we started a lesson with proportionality. So we've already kind of covered proportionality, and we've also covered scale drawings. But there's research has shown that in order for kids to really get a concept, it's best to teach them the concept, give them a few weeks or a few months, or actually a few weeks, not a few months, and then teach them the concept again. It's called spaced practice. And basically that reinforces the learning, it deepens the learning, it makes it much more easily for the kids to remember the concept and to understand the concept better. So that's what we're doing. All right, so here is the first thing that I wanted to cover. So one of the questions that you should be able to answer is, if I said, what does it mean for two things to be proportional? You should be able to tell me. And it shouldn't be a mathematical definition like, oh, if you look at a graph, if it's a straight line that goes through the origin, that's true. That is a true statement. But what I'd like for you guys to be able to do is to tell me what you think proportional means or proportionality means in your own words. For instance, if you were trying to explain this concept to a second grader or third grader or fourth grader, you wouldn't say, oh, it's when a straight line goes through the origin. They wouldn't understand that. But they could understand the idea of proportionality if you can explain it to them in some simple terms that they understand, right? And I think that you can. Most people, the concept of proportionality and proportionalness is, I think it's hardwired into our brains. So what I'm gonna do is I'm gonna show you guys a few pictures, and I want you to kind of say the first thing that comes to your mind, because I'm gonna show you. Now, before I leave this, here's another concept that research says helps students understand. It's called elaboration. And basically what that means is, if you can take a concept and you can put it into your own words, that's elaboration. That helps you learn. If you can explain that concept to someone else in your own words, that usually means that you really understand the concept. If you can't do that, then you probably don't understand the concept. That's called elaboration. It deepens your understanding and your knowledge, all right? That's what I want you to be able to do. All right, so now I'm gonna show you a series of pictures, and I want you to tell me the first thing that comes to your head. All right, here's the first one. What do you notice about this guy? If you are like most people, you're gonna say, whoa, that dude's got a big nose. Yes, that nose is not proportional to the rest of his face. And most people, when they look at this guy, they would say, whoa, that guy's got a big nose. Basically, what you're saying is, hey, his nose is not proportional to the rest of his face, or his nose is not proportional to a normal nose, right? But that's what proportional means, and everyone knows how to say that. Here's another one. What about this? This is called a Proboscis Monkey. And the first thing you notice again is his nose. Proboscis monkeys have huge noses, right? And part of the reason that people notice that is that their noses are not proportional. When you normally look at a monkey, you don't look at it and go, oh, that monkey has a big nose. But that, again, their noses are not proportional to normal. All right, here. What's the first thing you say when you look at this guy? Wow, that guy's got some big ears. One of the students said, man, he could hear my thoughts. I thought that was funny. Yes, this guy has huge ears. But when you say that, what you're really saying is that his ears is not proportional to the rest of his face. Or you're saying his ears are not proportional to a normal person's ears, right? But everyone understands when you see somebody like this, wow, his ears are not proportional. But we don't say that. We say, wow, he's got some huge freaking ears. But that is the concept of proportionality. Now, who's this? This is President Obama. One of the things that President Obama always makes jokes of himself is he says that he has big ears. He says that he has big ears. President Obama has said that about himself. And basically what he's saying is, my ears are not proportional with the rest of my body, or my ears are not proportional to the rest of my face. They're too big. Here's another famous actor who also has complained about his ears. Will Smith. He's complaining about his ears. And what he's saying is, my ears are not proportional to the rest of my face. They're too big. All right, now I don't know who this guy is. I just found this picture. But besides his messed up haircut, the first thing that you probably saw is you said, wow, that guy's got a big forehead. No. He doesn't have a forehead. He has a 7 head. That is a big head, right? But I'm not trying to make fun of him, but I'm trying to emphasize this point. Everyone understands when they see something that doesn't look proportional, they go, whoa, that guy's got a big forehead. What you're saying is his forehead is not proportional to the rest of his face, or his forehead is not proportional to a normal person's forehead. So that idea of proportionality is baked into our DNA. We learn that as babies when something looks, basically not proportional. All right, here's another example. Now, this is a picture of Rihanna. I think this is actually a beautiful picture of her. She looks really good here. But Rihanna gets criticized by a lot of people because of her forehead, right? Some people think it's not proportional. They think it's too big. I don't have a problem because I have a big forehead too. So I'm not going to criticize her because I can't talk. But here, now, this is Neo. You will rarely see Neo without a hat. He almost always is wearing a hat. Do you know why? Well, here's why. Because his hairline is receding and he has kind of a big forehead. So he puts a hat on, just like I have my hat on, so that the forehead doesn't look so disproportional, right? But my point is, when you see pictures or when you see people, you can look at someone and go, wow, that guy's got a big forehead. You're saying his forehead is not proportional either to the rest of his face or to a normal person's face, right? So that's the idea. Now, and that's an idea that you can say to a 2nd grader, 3rd grader, 4th grader, 5th grader, and they would understand that. That's how you explain proportionality to a kid. All right, so let's go. So now here's a picture of a kind of a average, normal human body. And I put normal in quotes because whatever that means, right? But this is just a normal image of a normal man. Now, so my question is, are these two figures proportional? And hopefully you would say yes, because they are, because they're basically the same copy of the same image. I just copied it and produced another one. They could be brothers, they could be father, son, who knows, but they're proportional. And what that means is I can take a number, and the number is 1, and I can multiply any part of this guy's body to get this guy's body. I don't have to use any different number, right? So if I can look at these guys and say, yeah, these guys pretty much match up, then they're proportional. So here's another example. Question, are these two guys proportional to each other? This guy's over here is bigger, this guy over here is smaller, right? But are they proportional? That's the key question. Now, some people think just because they're different sizes, they're not proportional, but they are definitely proportional because all I did was I copied this guy and then I shrunk him, and I shrunk the whole body, not just a part of his body. I shrunk his whole body. So basically these guys are the same guy, I just shrunk it down. So these guys are proportional, right? And again, I don't know what the the scale factor is, but I could find a number, let's say it's 5, and if I multiply this guy, size of his head, I could get this guy. But everything in here, I can multiply times 5. Everything in here can be multiplied by 5 to get this guy over here. If I'm multiplying this guy over here by the same number to get this guy over here, then they're proportional. And they are proportional. All right, so let's go. Next one. Now, Father's Day is coming up. So I just found these pictures. Now, this is a father and a son. My question is, are they proportional? Right? Now, it's hard to really tell exactly, but I would say they are proportional. Now, I would say they are proportional. Now, it's hard to tell, but this guy is going to grow up. He's going to probably look pretty much like this guy. So his, even though his head is smaller, when he gets bigger, his head will probably be about the same size. His feet are smaller, but when he gets older, it's probably going to be about the same size as his father's feet. So that means they're proportional. Even though they're different sizes, they still are proportional. Now, I got a couple more pictures. Here. Now, I showed this to the class. They didn't think that these guys were proportional. I think they are. Even though the father is definitely bigger, there's a point where you could probably find a factor that you can multiply this guy by to get this guy, right? One looks more bulky, but again, just because he's more bulky or bigger doesn't mean that they're not proportional. It's like, is there a number that I can find that will get me from this guy to this guy, and I can use it for pretty much all of his body? Yeah, I think you can. So I would say these guys are proportional. It's not the best example. Here's another guy. Let me turn it this way so you can see it. This is a father and a son. The question is, are these two proportional? I would argue that they are. So even though he is much smaller than his father, I think like if you were to look at this, you could probably find a factor that you can multiply this by. Let's say it's 7.5 to get his father's head. Or you can take something and multiply the hand size to get his father's hand size. Or you can take something 7.5 and multiply to get his father's feet. That means they're proportional. Even though one is bigger than the other, they can still be proportional. So don't get tricked into thinking just because two things have different sizes that they're not proportional. That's the whole point of scale drawings. One thing is going to be much smaller than the other, but they can still be proportional. All right, so here. Now, let's look at this one. This is Shaquille O'Neal, and this is Earl Boykins. Now, the question is, are these two proportional, right? And I gave you a couple numbers to kind of help. Earl Boykins is 5 feet 5 inches. Shaq is 7 feet 1 inch, right? So Shaq is obviously bigger than Earl Boykins, right? But the question is, are they proportional? Now, here's the kicker. Earl Boykins is definitely not as tall as Shaq, but he's over half Shaq's height. 5'5" is definitely over half of Shaq's height. But now, if you look at their feet, Earl Boykins wears a size 9.5 sneaker. Shaq, on the other hand, has a size 22 foot. His feet are twice as big as this guy's feet, even though his body is not twice the size as Earl Boykins' body. So these two guys are not proportional. It's not just that one is small and one is big. It's that I can't find a number to multiply the body by to get Earl Boykins' body, and then use that same number to get from his feet to Shaq's feet. I would have to use two different numbers. If I have to use two different numbers, they're not proportional. All right, so these two guys are not proportional. Now, having said that, these two guys are proportional. Just because one guy is smaller than an X doesn't mean that they're not proportional. Now, here's the fact that I want you guys to see. Are these two guys proportional? Absolutely not. Even though the bodies are the same, this guy and this guy, the head size are completely different. right? So in order to go from this guy to this guy, I can multiply times 1 to get the same body size, but I can't use that same factor to get this guy's head size. I'd have to multiply, it looks like, by like 4. So I'm using 2 different numbers, right? One for the body and then one for the size of his head. And if I have to use 2 different numbers, then they're not proportional. If I use the same number for any part of the body to get this guy's part of the body, then they're proportional. I hope that's, here's another picture. Are these 2 guys proportional, right? Well, they look pretty much identical until you start to look at their hands and their feet. So these guys, his hands are much bigger than his hands. His feet are much bigger than his feet. So they're not proportional, right? Even though their bodies up here and everything else looks proportional, their hands are not. So if I can't take this guy and use the same number to go from him, multiply the same number to get this guy over here, if I had to use 2 different numbers, 2 or more different numbers, then they're not proportional. Now, hopefully that concept. I don't know if you guys know, this is a basketball player. This is a woman's, a female reporter's hand, and this is a basketball player's hand. I don't know if you know who this is, but he has humongous hands, some of the biggest hands in the NBA. You might know who it is by that hint. Now, here's another picture. This guy has his, and it's Kawhi Leonard. Kawhi Leonard of the Los Angeles Clippers. I think this picture was taken when he was a Toronto Raptor. But this is a female reporter's hand. She is 5'7", and he is 6'7". But look, man, his hands are humongous. So his hands are not proportional, right? So these 2 are not proportional. Let me go look. In fact, Kawhi's hands are his hands are some of the largest hands. They're not proportional to the rest of his body. They're 52% larger than like the average guy's hands. So like if you looked at, even though he's a tall guy, his hands are still bigger than someone who would be a corresponding size, or kind of an average human size, right? So they're going to be smaller and their hands are going to be smaller, but his hands are even bigger. So he has some really large hands. But anyway, okay, hopefully that didn't confuse anybody. All right, so there's another fact to him. So here's what I want to go. Let's see here. This is where I want to get to. When I look at these 2 drawings or these 2 rectangles, my question is, are these 2 drawings proportional, right? Now, I have numbers. Now that I have numbers, I can really say with some precision whether or not these 2 things are proportional. And they are, because all I would have to do is if I multiply this number by 10, I get this number here. If I multiply this number by 10, I get this number here. If I multiply this number by 10, I get this number. I multiply this by 10. So everything, if I multiply this, let me change this color. If I multiply any number up here by 10, I get the corresponding number down there. That means that these 2 figures are proportional. Even though one is bigger than the next, they're still proportional. Now, here's the idea that you guys have to use for this week's assignment. All scale drawings are proportional. All scale drawings are proportional. You assume that when you see a problem that says, oh, here's a scale drawing of this, you should say, oh, that means they're proportional. You don't have to question whether they're proportional or not. You might have to figure out what the scale factor is or the scale factor of proportion is, but you should assume that they are. And once you know that, it makes these problems much easier. So here's our first problem. This is taken from Khan Academy. It says a scale, keyword. Once you see that word, you should be thinking, oh, that means these 2 things are proportional. A scale on a map shows that 3 centimeters represents 10 kilometers. What number of centimeters on the map represents the actual distance of 25 kilometers? So now, because they're proportional, because we can assume proportionality, we can set up a proportion. 3 centimeters is equal to 10 kilometers. And then on this side of the proportion, we're going to put 25 kilometers. And because we see that the units are in kilometers, we're going to put it down here on the bottom on the right-hand side. And up here, we're just going to put X. Now, that's the proportion. We've set up a proportion. Now, we should be able to set up proportion. If something is proportional, you should be able to set up a proportion to solve it. Now, all you have to do is cross multiply. 3 times 25, 3/4 is 75 cents. So it's going to be 75 over 10. So X is going to be 7.5 centimeters. So that's what you're going to put in here. That's how you would answer. This is Khan Academy. This is a Khan Academy assignment. Scale drawings. Let's look at another question. It says, okay, Gwendolyn draws a hot dog on a graph paper using the scale shown below. And the hot dog has a length of 9 units in the drawing. So we're going to try to figure out what's the actual length of the actual hot dog. So here's what we have to do. We're going to use this scale and we're going to set up a proportion. So it says this is 1, 2, 3, 4, 5, 6. So 6 units on this graph is equal to 10 centimeters. That's our scale. So now on this side, we're going to take how many units? It said that this is 9 units. If you measure this and count it, it'll be 1, 2, 3, 4, 5, 6, 7, 8, 9. So it's going to be 9 units. And then this is what we're going to solve for. We just cross multiply and solve for X. So let me get a different color and let's solve it. So this is going to be 6X is equal to 9 times 10, which is 90, right? And then the last step is divide both sides by 6. So X is equal to 15. It's going to be 15 centimeters. That's how much the hot dog actually is. That's the actual length of the hot dog. Okay, that's the assignment for this week. Set up your proportion because scale drawings are always proportional. Set up your proportion, solve for the unknown. I got one more. All right, we have a figure here. It says it's got a scale drawing. So it means that these figures are proportional. So let's set up a proportion and solve it. Now, it really doesn't matter how you set it up as long as you're consistent in comparing the same things. But because this side goes with this, I'm going to say X is proportional to 7.2 and 3 is proportional to 4. There's our proportion. Now all you have to do is cross multiply. It's going to be X equals 3 times 7.2 over 4. 3 times 7.2 is 21.6 divided by 4. And then 21.6 divided by 4 is 5.4. So the answer to this, X equals 5.4. We don't have any units on this one, right? So we're going to compare this side to this side because that's how they're oriented. And we're going to compare this side to this side, right? So in this particular case, they don't give us units. We got to just look at the figure and use the sides, corresponding sides, to set up the proportion. Same idea, right? I got one more question. Actually, I'm going to end on this. So that's the assignment for this week. It's going to be scale drawings. I'll do one more video using some iReady problems for Wednesday. But the idea is if they are proportional, let's go back. If you see scale drawing, you should assume that they're proportional, which means that you should be able to set up a proportion. Boom, 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 boom. One of them, you'll have an unknown. That's what you're going to solve for. That's what you're doing this week. All right, guys. I think this went a little over, but I hope that it's helped clarify what proportionality and scale drawings are. Let's stop.